If we look in this car, the differential is actually a small piece in the middle here, and that's because we have independent rear suspension. The whole point of the CV joint and what it is constant velocity joint. So we don't end up with the same speed variation. We need this on there to actually do a proper measurement. Now that we have the flange on, torqued up, check the rotating torque, we can get to actually measuring this drive shaft. I have here a drive shaft out of another car, and it's going to be a great reference so you understand what I'm talking about. Now, first of all, the front of the drive shaft, we have a slip yoke. So this is the actual slip yoke, and this part of it goes into the transmission, and because it's splined, it can move back and forth. So if we look up at the transmission here, right now I have a plug in there so that it doesn't get dirt inside, but that's where this goes into. Now, the shaft itself, when we're measuring the shaft, any measurements that we take with a universal joint, so this is a universal joint, adding to this shaft, another universal joint at this end. Now, the thing with a drive shaft is, if you take a drive shaft and run the drive shaft straight, when it rotates, this shaft stays the same speed as the output shaft, and if it's completely straight, this will not speed up or slow down. If I run it on an angle here, and I run this end on the same angle, what happens is, as this shaft rotates, every quarter turn, the speed of the drive shaft speeds up and slows down. So the drive shaft itself, the speed oscillates. And so it's very important that if you have an angle on your front U-joint, you have a relatively similar angle at the back. Because if you don't, you're going to end up feeling those speed variations when you're driving down the road if you have a large angle. And on this car, we have large angles. So I'm going to show you how we have to deal with that. We'll take a look at the diff first. If we look in this car, the differential is actually a small piece in the middle here, and that's because we have independent rear suspension. Conventional cars, we might have a straight axle, and that differential is all one piece. With this, if we go over a bump, one side can move independently of the other. This differential housing is mounted to the frame. And in this case, not all cases, some of them on street cars have bushings and stuff, but this is a solid member mounted to the frame. Now, because our angles are off, other options you can run is with a CV joint. So a U joint has that speed variance where a CV joint does not. I'll show you what I'm talking about with the CV joint. So we have the differential here, and then we have the first constant velocity or CV joint right here. And then we have the axle shaft right here, and then we end up with the outer CV joint. So the whole point of the CV joint and what it is constant velocity joint. So we don't end up with the same speed variations. Whatever speed is here is transferred into here, is transferred into here. So the advantage of this is I can change and make these angles not even close to the same, and my input and output speed does not change. Now, a lot of the time you might have an angle that's close or whatever, and so it's very common to see an actual drive shaft like the one that I was talking about with the two U joints on it. And they'll put one CV joint on one end and U joint on the other. Because the angles aren't really far off, you don't end up having problems. But in this case, all of our angles are really wonky. So we are going to have to get a drive shaft made with CV joints on both ends. Okay, on the back of the transmission, I'll pull this plug out. And if we see here, we have a grease seal that has a big floppy thing over the end. We have our spline shaft in the inside. Now, what we need to do is measure this drive shaft. And if I was to measure this shaft, I'm not measuring from the end of this. What normally you do is measure from the seal. And on these, you have to actually measure from the actual seal surface there, which is the same as in there. So if you're taking the measurement, you got to get to that seal, and then we'll go look at the back. If we were going to be using a U-joint, what we would be doing is measuring to the middle of the back U-joint, and that would be this flat surface here. So we'd measure from the seal at the front to this flat surface. But having that we are going to be putting universal joints in this, we need to put a flange on here. Now, this is really interesting because the manufacturer of the differential doesn't make a flange. And I called around trying to get flanges, trying to get stuff figured out, and I ended up getting a hold of G-Force Engineering. Actually, it's G-Force Performance Engineering, I believe. And if you want to talk to somebody that actually, this isn't a plug for, like, I'm not sponsored by them, but if you want to talk to somebody who actually cares about a hot rod and what they're doing, and as well, they are ramping up. They, I guess, are redoing their production line for building drive shafts. I would have them build this drive shaft. Unfortunately, they're not ready yet. But Billy, he talked to me, gave me a lot of information, and he ended up finding me this yoke for the back. So I talked to the differential manufacturer, and they don't make the yoke. They told me what spline count this should be. I had to take this off, and I had to count the splines to be sure for Billy. I did that. He sent me this yoke. Now, we need this on there to actually do a proper measurement because we have to measure to this face. So talking to the diff manufacturer, I said, okay, what kind of setup is inside of there so that when I pull this off, I get it on in the same, with the same preload for the front bearing. And their instructions were to me, which is pretty normal. You measure your rotating torque. And on this one, it was 40 inch-pounds, and he said it should be around 200 foot-pounds. He said they'll be torquing it to 200 foot-pounds, give or take, and then we measure a rotating force. So I'm actually going to change this yoke, and I'm going to show you how we measure that rotating torque. Now I have my trusty, really old beam style torque wrench. Has anyone ever used one of these or seen them? They're really cool. They're very accurate. Now this is in inch-pounds, and what you want to do is you want to get the rotating torque going. So I'll get you to zoom in there. And not the break loose torque, but when it starts rotating, what it sits on. So it is torqued up, and we are on 40 inch-pounds. And that is exactly what it was when I pulled this apart. So now that we have the flange on, torqued up, check the rotating torque, we can get to actually measuring this drive shaft. On this end, I got my tape measure right against the end of the tailstock on the output of this transmission. Now, I took a caliper and measured, and that is just under 1/8 of an inch in that seal. So we'll stretch it out and go to the back. So now what I've done here is, if I take the math and add that just under 1/8 of an inch, we are going to be 55 3/4 of an inch from that seal to this face. So we'll talk about independent rear suspension versus non-independent rear suspension, because your measurements will change on those. On independent rear suspension, well, the differential doesn't move up and down. It's fixed to the chassis. So the wheelbase of the vehicle doesn't change, move. The distance from the tranny to the pinion on here doesn't move. So you can have it up in the air, wheels hanging, it does not matter. If you have a solid rear axle, the swing of that axle with the suspension actually changes the distance from the output of the transmission to the differential. And that's why there's a slip yoke. But if someone is going to be making a drive shaft for you, the most important thing with a live axle vehicle, so non-independent rear, you have to have it with the weight on at ride height to give that initial measurement. You can do a couple other things just like I did here, even though this is independent rear, I'm building this car. So we set the ride height with a bar in here. So took the shock out, put a bar in here, and that makes it so that as we're working on this car, it always stays at ride height. And when you're building a hot rod, that's a great idea. Now, the one of the most important things that I want to say with this video is if you actually want to talk to a real person, call G-Force Performance Engineering, because Billy there, he actually cares about what's going on. And again, I just want to thank him so much, because I was having a nightmare trying to find a proper flange for this differential. So thank you again, and thank you all for watching. And if you have any questions or comments, please put those in the comment section, and like, share, and subscribe.